In this video, we're going to talk about how to write a formula. This is kind of a weird task, by the way. How to write a formula to calculate the distance from some random point to specifically the point -1, 2. So this is something that you should be able to, you watch the video, you figure out how to do it, and apply what you've learned to a problem in our problem set that we're working on. And this is just for a kind of a portion of a larger problem, right? So we're writing a formula for calculating the distance from some random point up to the point -1, 2. So I've kind of drawn this diagram out here to show our random point. Notice I haven't drawn it on on grid lines, so it's trying to imagine that it's sort of just in space somewhere. Of course, the point could also, I suppose, be over here or up here or out here, so it could be anywhere. I've just kind of specifically drawn it here because I wanted a diagram so we could look at something. We do need to be careful we do that, however. You don't want to make assumptions based on how your diagram looks that are only true when the diagram is like it is, but I think we'll avoid that. So, we're finding distances, so this is Pythagorean theorem again. Now, remember, we talked about this in an earlier video when we were moving Pythagorean theorem from Pythagorean theorem into distance formula. We talked about how we could rewrite the Pythagorean theorem in more of a formula sort of way. So we had a squared plus b squared equals c squared. And when we fill it out this way, at the very end, we have to take the square root on both sides in order to get the final answer. And that requires us to act on both sides of the equation. But in a formula, we just want to be able to plug something in and just spit out an answer without having to act on both sides of the equation. So what we do is instead of taking the square root at the very end, we just start out by putting everything underneath the square root bracket. So now we'll do our a squared plus b squared, we'll add them together, and then they'll automatically be inside the square root bracket, which you could actually punch into a computer and have it do it that way. All right, so in this case, we need to calculate our a and our b, and I'll put my a and my b here, and it can go either way. A and B, you can interchange them, so I could put A down here and B up here, and I'd pretty much come up with the same thing. Right? The formula might look a little different, but it would function the same way. So how are we going to calculate A? All right, so A. Remember, we talked about this in an earlier video, but A is the horizontal change between the 2 points. So as I travel from the first point to the second point, I end up further to the right, my right, this would be your right. I end up further to the right than I was, and that's my change horizontally. So keep in mind, this doesn't mean I'm traveling over and then down. These markings are just showing, I am so far further to the right than I was when I started. That's our horizontal change. We mark that as the little triangle as delta, delta x. So how far did we move to the right? And we calculate that by taking our ending point, which is just going to be x, and we're subtracting our starting point, which is -1. X minus -1. And instead of minus -1, let's simplify that to make it x plus 1. I should specify, by the way, since we don't know what the coordinates are, we're just going to call them x and y. Or maybe we could call them, I don't know, x sub something or whatever, but we don't know what our coordinates are, so I'm just going to call them x and y for now. And they're going to be our inputs. We're going to plug those numbers in to our formula. So next we have b. So that's as we travel from this point down to the point xy, we've dropped b units, whatever b is. And so to calculate that, that's our change in y. And again, just to be clear, we're not talking about starting here and traveling over and then down. We're traveling in a straight line from this point out to our unknown point xy, in a straight line. But once we've completed that movement, we find that we are so many units over and so many units down. And down part is called delta y. We pronounce this delta y, and it means change in y. So how much did the y coordinate of our point change? It changed from 2 to something. And how do we calculate that? Well, we take our something, which is our new point, whatever it happens to be, and we subtract our original y coordinate, which is 2. And then there's no simplifying there, since y minus 2 is fine the way it is. So this is our b, and this is our a. And now we just need to plug those into our Pythagorean theorem formula up here. So let's see, I'll start out. So our a is y minus 2 squared plus our b, which is x plus 1 squared, equals c, our distance. So let's test our formula out. Let's pick an actual point. Say, for example, if I travel straight down to here. So this point is -1, -1. Okay, so let's plug those in as our xy coordinates and see what happens. So let's see. We have y, that's -1. So -1 minus 2 squared plus our x coordinate is -1. -1 plus 1 squared equals c. So let's see. Make sure I keep my square root bracket. So I'll redraw it every single line, or else you'll forget that it's there. -1 minus 2 is -3 squared. And remember, if you punch this into your calculator, if you don't put the parentheses around it, it's liable to tell you that -3 squared is -9, because the calculator is going to follow order of operations, and it's going to square first, then take the negative. But what you want is -3 squared, which is -3 times -3, which is +9. Plus -1 plus 1, that's 0 squared, is c. So then, let's see, this is 9 plus 0, which is 0, is c. And the square root of 9 is 3. Okay. And there we go. It was 3 units. We can count spaces to see if that's true. So our formula works. We could try some other points, but it will always continue to work. So again, we selected, we called our random point. We're trying to write a formula that will calculate the distance from any given point to the point -1, 2. So we call the coordinates of our random point x comma y to calculate our a, which was our horizontal change, which Picard called delta x, and that's not super important. I just want to introduce that terminology so that you know what's out there. Oops, dropped a pen. So we take our x, and we subtract the original x coordinate, and that will give us the distance between the two x coordinates, which is the amount that the x coordinate changed, or the horizontal change, or if we were to draw on our right triangle, the a value in a squared plus b squared equals c squared. To get this formula here, which we simplified in this case, but that might not always be necessary. And then, to get our b, that's the vertical change, I took the y coordinate for the point that we don't know yet, so that's the one that we're going to plug in. That's our variable y, and I subtracted the original y coordinate, which is 2. So y minus 2, and that gives us the vertical distance between them. This is the amount that the y coordinates changed when we went from a y coordinate of 2 to our unknown y coordinate. Right, so that's the change in y. And that's our a and that's our b. We just plug them into our Pythagorean theorem formula, right? It's our altered Pythagorean theorem equation to get this formula right here. And this formula will give us the distance between any 2 points, or not any 2 points, between any point and the point -1, 2. All right? So there you go.